It's now up to you. So we're going to hear your first talk with lots of live coding also about progressive web apps. So give it up for Simona Cotin.
Thank you. Thank you, Martin. Sorry for the technical difficulties. It looks like my Mac has died, or a part of my Mac has died. Is everyone having a good Tuesday? Wednesday. Oh, sorry, I've lost track of time. Did you have a good Tuesday, though? I feel like Tuesday is the best day of the week. Do you have this superstition of Tuesdays be the 13th of Tuesday being the worst day of the month or something? No? That's Friday. Okay, cool. For us, I come from Romania, and for us Romanian people, Tuesday the 13th is the worst kind of day you could ever have. But it's not going to be today. Cool. So today we're going to talk about progressive web apps. And as Martin mentioned, I'm a developer advocate. And the reason I started looking into progressive web apps was actually a very selfish reason. Because, as you can see here, many people will think that as developer advocates, we party a lot, we have a lot of fun, and they're very jealous about that. Other people will think that we burn through their money, we travel a lot, we spend a lot of money on just visiting really nice places. We think that we are super in control of the world and we're rocking it and we're super rock stars. But actually, what we end up doing most of the time is sleeping in airplanes. And not only airplanes, but also in trains on our way to the airport, also in hotels that seem to be very nice, but they actually have really bad internet connection. So all these places, that's what they have in common. And guess what progressive web apps helps with? Anyone? You get a t-shirt at the end of the talk. Yeah, so progressive web apps help us with spotty internet connections or whenever we're offline. And that's why, well, this is me whenever the internet is not great. And my name is Simona Cotin. I work as a cloud developer advocate at Microsoft. You can find me on Twitter at Simona_Cotin. If you have any questions about, basically about Azure, because right now I'm focusing a lot on Azure. I'm super passionate about serverless on Azure, but also my background is with Angular and TypeScript. So if you have any questions about Angular, I'm super happy to help there as well. And I'd like to introduce you to Bit. This is our team's friend, and you're gonna see it in many of my slides. Basically, it's a raccoon, and just as raccoons go anywhere and everywhere, that's what us and our team, the CDA team, does. We go where you are. Cool. So today, we're gonna have a refresher into what PWAs are. We're going to dive into which are some of the main concepts. We're going to see why Angular loves PWAs. We're going to look into which are some of the differences between native and PWA and kind of try to answer the question, should I go PWA or should I go native? We're going to look into some of the gotchas in terms of if you're building a PWA, what should you keep in mind so that you're prepared for whatever the web API has there for you. And then we're going to look into the tools that we have available. Cool, so what are progressive web apps? For those of you who know already, this is going to be a good refresher. So progressive web apps are basically web applications that are regular web pages or websites, but they basically appear to the user like traditional applications or like native applications. So the goal of progressive web apps is to offer that great experience that native applications give to our user. Another definition that I absolutely love is that they're just websites that took all the right vitamins. Who knows where this definition comes from? Anyone? Well, guess what? I know. Alex Russell. That's great. Yeah. Definitely. Yeah, so Alex Russell, for those of you who don't know who is, he's a Google engineer that, together with his wife, Frances, they coined the progressive web apps term. And they were doing that while they were having dinner, like every software engineers couple does. We go out for dinner and we chat about anything related to web or to software or to engineering. So what they did was basically they came up with this list of what makes a great user experience on the web and what makes up a progressive web apps. And I'm sure that some of you might have heard, might have gone through this list. Basically, with the progressive web app, we're aiming to enhance users' experience. So the better the browser is, or the more features the browser supports, the better the user experience will be. We're also aiming to build applications that fit any form or factor. Like it looks good on a tablet, it looks good on a mobile, it looks good on a desktop. So trying to be responsive. Also, my favorite part, I wish every website was a progressive web app, it's connectivity independent, which means that if you're offline or if you have a spotty network connection, definitely your website will still be responsive and you will get some data. It should be app-like. It should feel like an app, like the interaction and the navigation should be similar to a native application one. It should stay fresh. So whenever we're back online, our data should refresh. It should be safe because the service worker is so powerful. We should definitely make sure that our application cannot be tampered with. It should be discoverable. The web is basically a collection of links, and our apps should be discoverable. We should be able to search on the web and find the progressive web app. And re-engageable, who here doesn't like notifications? You see, no hand. Everyone loves notifications, maybe Burke. So it should be re-engageable. We should have a way to bring our user back. Imagine things like talking on Facebook with your family. You receive notifications with their messages. You want to be able to re-engage with your family. So progressive web apps should be able to do that as well. Send notifications just like we receive from native apps. And finally, it should be installable. Make the experience as great as possible, have your app available on your home screen. And linkable because we want to be able, I want to be able to share links with Sarah. So yeah, progressive web apps. So this is a huge list of words, but how do we actually take this into practice? We have this thing that's called the baseline appiness, and a baseline appiness includes a service worker, or includes service workers, and then we also have a web manifest, and all of this is delivered over HTTPS. So service workers, web manifest, everything delivered over HTTPS. I mentioned that our service workers are super powerful, so you can, because they do have the power to change the content, we definitely want everything to be delivered over HTTPS. So diving into the main concepts here, what are service workers? They are proxies that sit between the web page and the network, and they provide cached versions of the site when no network connectivity is available. And another definition that I love as well, which comes from the progressive apps from Dean Allen Hume, is that you can think of your requests as airplanes that are taking off, and the service workers is the air traffic controller. It can load everything from network or even off the cache. So it's deciding where do we want to satisfy our requests from. Does that make sense? Yeah? Cool. A question that we get very often, and until recently we couldn't have said yes, is service worker ready? And the answer is yes, because now all the major browsers have released their support for service workers, including Safari and Edge, which were the last ones to hop on the train. This is a website from Jake Archibald, who's one of the people that have worked on the service worker spec. And I recommend, if you're not following his blog or if you're not following him on Twitter, you should definitely do that. Okay, cool. So just to have a diagram of the previous definition, in terms of service workers and like which are the actors, we start with a web page, and the service worker sits on the same side as our web page, and the dotted line there is basically our wire, and then we have our backend. And on the same side as the web page and as the service worker, we have sitting the cache. And we can imagine a user making a request to the web page. And then this request is being intercepted by the service worker. And the service worker analyzes the request, and it thinks about it, and it works really hard, and it decides to go make the request to the backend. And this is based on the rules that we as developers define, or on the network availability. And then the backend responds, and then the service worker sends back the response to our user. The other option is where the service worker decides to, instead of getting the request, the data from the backend, it decides to get the data from the cache itself. Because we've decided that we want to optimize for performance maybe, and just initially get the data from the cache, and only after that maybe retrieve the data from the backend. And then the cache, we get the data from the cache and reply back to the web page. How do we actually get started with the service worker? We have to register the service worker the first time the user visits the page. So we do that using the navigator object and the service worker, but we have to check whether the browser supports service workers or not. And then there's two things that are important with service workers. We have a scope for every service worker out there, and we have a life cycle. And the scope defines which requests does the service worker control. So which is the domain that it can reply to. And this is very important. This is scope that's separate from our web apps scope. And it's important to define the scope because you can imagine that if the request, the scope is shared for service worker is shared among different web pages, our requests can be controlled by that service worker, and we can do bad things there. So here, the default scope is the current folder where the service worker is defined, and then if we were to maybe add the work folder or the work path to our domain, that's where that's the request that our service worker will control. Does that make sense? Yeah? Cool. Okay, and then the life cycle. So we start with no service worker, and then once we register a service worker, we go into the installing phase. And this is where we cache our data, we cache maybe the assets that are critical to our application, and we want to be able to retrieve always from the cache. How many people here are familiar with the app shell concept? So app shell basically defines the basic structure of our application. You can imagine when it comes to a native app, if you don't have any connectivity, you're always going to see the navigation bar, you're going to see some top bar with some colors, or like a basic structure of our application. And this is what the app shell is as well, because we want to replicate the native apps kind of behavior. We want to create the same concept on the web. So whenever we don't have any kind of whenever we don't have network, we still want to be able to retrieve that app shell, that basic structure of our application from the cache and still display something to our user, because that's very important. So during the installing phase, we're actually caching what's critical to our application. And then once the installation is done, we get into the activated lifecycle step. And if we didn't manage to download all the assets that are part of our app shell, or something has happened during the installation phase, then we might get an error, which means that our service worker will just be dropped, and when the user visits the page again, we'll reattempt an install. And then the service worker goes into idle, and it can be triggered or activated by either a fetch event, so we're intercepting requests to the backend using fetch, and it can be triggered by that type of event, or it can be terminated and then woken up again. So this is how this looks like in code. On line 1 there, you can see that we can listen to the install event, and by calling event.wait until, we're basically saying that we're waiting for this event to finish until we're caching all the assets. And in this case, we're only caching a cat.svg that we want to show in our application. And then we can listen to the activate event as well. There's not much we can do there. Maybe we can console log something. We're doing that on line 10. And finally, we are listening to the fetch event. And this is where the fun happens. So when we're handling the fetch event here, we can basically understand what kind of requests we have. And then we can respond with whatever content we want. So in this case, if someone asks for a dog picture, we're going to return a cat picture, because we're cat people. And this is what I mentioned before when I said that service workers are super powerful. So basically, they're like a small server sitting in our browser, and we have full control. So you can imagine that if we weren't delivering our content over HTTPS, maybe someone could interfere with our request and just return something else that we didn't want to. In this case, it's voluntary. This is what we wanted to do. Okay, cool. So what about testing? How do we test service workers? Well, in Chrome, we have this tab that's called Application. How many of you have seen it before? Okay, there's quite a few hands here. Cool. And in this tab, we can see the manifest.json file. We can see the service worker. We can see its status. We can test our application to see how it reacts when it's offline, but also when was our service worker activated before. Can you see the text there? It's quite small. Okay. We can have a look at this now in the browser. So I have this PWA that I built. I wish it looked better. I'm currently looking for a home in the UK, and I was aiming to build an application for myself. But right now, it's still in the works. So far, we have just a menu here, and then we can see maybe a list of properties that are for sale. Currently, obviously, houses in the UK are not very cheap, so yeah. I can also see a list of houses that are for rent. As you can see, part of a progressive web app is having a responsive app. Currently, my app is not very responsive, so I should fail. And then I can also trigger notifications in this app. So I can subscribe for notifications, and I can receive messages from publisher. And then I can also sign in. I've implemented this functionality using the Auth0. Are you familiar with Auth0 product? Yeah, it's authentication as a service. Perfect. Okay. Okay, cool. So in the application tab here, we can see that we have access to the manifest .json file, and we can either see this UI, which shows us which types of icons we have, and what's the short name of the application, but this is something we're going to talk about later on. But in the Service Workers tab, we can test things like, how does my app react when I'm offline? So I can just go ahead and check the offline checkbox here, and if I refresh the page, in theory, I should still be able to see the content that has been cached for me. And then I can also see that the last update for the Service Worker happened on the 30th of May, which was today, afternoon. And I can see the status, it's activated and it's running. We can run tests like push or sync for our service worker. We can also maybe unregister the service worker, and then the cute dino will appear. And then if I refresh the page again, I will see the UI that we've seen earlier. So this is how we can test our service worker, but further on, we can actually debug our service worker in the browser. So we can just go to the source of the service worker, add breakpoints, like in this application in particular, the service worker is ngsw-worker, and I can go ahead and maybe add a breakpoint here in the handle fetch method, which basically handles the fetch event. And if I refresh the page, I will be able to step through all these breakpoints and see things like what's the request URL, and see if we're caching, if the content is cached or not. So this is something that we've all done before. We've stepped through code. We can do the same for service workers. So it's nothing really super new. Okay, let's say that we have bugs, because it can happen with service worker. Sarah has a great story here where she added the service worker to React Fest, I think, website. And what happened to them was that they couldn't unregister the service worker anymore. They didn't. You didn't handle the unregister step or something?
Unregistered, because marketing wanted on Squarespace. So basically, you had to buy another domain.
So yeah.
It's not even funny. It's funny.
So everyone that was accessing the React Fest website, they were seeing the old version of the website, the cached one. Yeah, to the new domain. So careful with the service workers. It's important to have the unregister option there. Okay, cool. So now with service workers, we are able to cache our sources. We are able to cache our content. And we are able, whenever we're going offline, we can intercept maybe the fetch event, and we can check whether we're again online and refresh the content that we have stored in our cache. And our application is discoverable by default. So going back to the 10 words that we've seen earlier, we can say that we've achieved 3 things, which makes us really cool. So then the next thing that we've seen is the web manifest. And with the web manifest, we're basically making our application installable, and we're describing things like what's the name that we're going to use when we're installing our app, what's the name that's going to appear on the home screen. We're also describing things like what icons we're going to use for that. So this is the JSON file that we can use to define the web manifest. And you can see here, the short name is basically the name that we're going to see on the home screen. The name of the application is what we're going to see in the pop-up that says, do you want to add this to the home screen? The icons, based on the types of devices that we have available, we're going to generate different sizes. And then the start URL allows us to define which is the URL that we're using whenever the app is started. And the cool part with the start URL is that we can also track things, like using the UTM source. We can see how many users have opened our application from the home screen and how many users have opened the application from the web. And this way we can make our application or understand our users' behavior. The background color is what we're going to use for our app, maybe in our splash screen, and the theme color is for our top bar in the application. This makes our application installable. We add more things to our list of done, 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 done. And then the service workers need to be served over HTTPS because we want to make sure that our content cannot be tampered with. So yeah, we have all these five checkboxes, and this is what makes the baseline appiness. We have to achieve this so that we can say that we have a progressive web app. So then if we go to Angular, and this is where we can use the Angular CLI. And this is specific to Angular, but actually both React and Vue have the option to have a CLI of their own, and you can generate service workers and you can generate progressive web apps using their CLIs as well. So we're going to go ahead and do this live. Has any of you, how many of you are Angular developers, or how many of you use Angular? So that's probably half the room. How many of you have generated progressive web apps using Angular? Okay, maybe just 3 hands out of 80% of the room. Okay, cool. So this might not be news to you, but basically to create a progressive web app, we can use the CLI, and we first generate the app, or if we have a new one, we can just add a new progressive web app. I'm just going to go through the slides because this might be just too familiar. So these are the files that get generated when we're adding the progressive web app to Angular. So we generate a new app using ng-new, and then we give it a name, and then we do ng-add, and we add Angular PWA, and we can specify the project, in this case my PWA, or if we're already in the project's path, we can just add it there. And then the files that get generated or that get changed are the angular.json configuration file. Also, there's a new config file that specifies the rules for caching content. The first one, the angular.json file, we enable the service worker build here by just setting the flag service worker to true. And what this will do, it will copy a service worker that has already been created by Angular. It will copy it from the npm package into our dist folder, and then this service worker file will use the runtime configuration that we have defined in our JSON service worker. And then we are also setting the asset. We're copying the manifest.json file that has just been generated for us into the assets folder. And then in the module, in the app.module.ts file, we are importing the service worker module, and then we are registering our service worker, and we are enabling only for production. Do you know why we're doing this only for production? So HTTPS is one reason. The other reason why we're only running service workers in production is because while in development mode, we want to make sure that we have the latest content. So instead of, when we're running service workers, everything's going to be cached, right? And we might end up testing and kind of banging our head against the wall for hours because we are seeing old content. So instead of doing that, we are just enabling the service worker only for production. So how do we debug the service worker itself? We're running the application. We are building the application for production, and then we are running our application from our local, but running the production bundle, and then we can debug the service worker as it is. Yeah. Does anyone else have another question? No? Okay. Okay, cool. So this is the service worker config file that gets generated. And as I mentioned before, we have this concept of the app shell, and this is what we're caching first. So in the first, on line 3, you can see that we're defining the assets groups that we're caching. And we're defining there the resources that we are caching whenever we're installing the service worker. And that's what we understand by prefetch. So prefetch, we are caching things immediately. And here you can see that we are caching the index.html file, favicon, and then all the CSS and the JavaScript files that we have defined. And then in the next line of assets, we are caching the images that we have available in our application. But these ones, you can see that for them, the install mode is lazy. And what this means is that we are not going to try to cache them during the install event. We are going to cache them once the service worker is activated, because we don't want to spend precious time caching these resources. They're not part of our critical path. They're not part of our app shell. Okay, and then the update mode is prefetch. So whenever a change happens, we're gonna immediately attempt to retrieve them from the network. So then we have to build for production, because we mentioned that we want to test our application from production. And then this is what gets generated. And this is where you can see our NGSW worker file, which has been copied from NPM. And then the NGSW configuration, which is our runtime configuration. Okay. In order to test our application, we can use Lighthouse. Maybe I can just run this locally, and this way you'll see on the real app that I've just created, we can see how my application scores. So in order to test whether an application is progressive or not, obviously there's a lot of metrics that we can consider. One of them is performance, but then there's also a checklist that gets integrated with Lighthouse. And Lighthouse is available in Chrome, in the developer tab, but also we can use Lighthouse in NPM as an NPM package, and we can integrate that with the CI/CD process. So we can, whenever we're making changes to our application, we can run tests and we can run Lighthouse to make sure that our application is still progressive. Okay, so I'm gonna click Perform an Audit. And it's going to evaluate things like the performance of my application, if it's progressive or not, best practices, accessibility, and SEO. And if we think back of what makes our application progressive, so here Lighthouse will check things like whether a service worker has been registered for our application or not. And the way it's going to do that, it's going to test our application in offline mode. It's also going to test whether our application has a manifest.json file registered, because that's important, that's trivial, and that's crucial to a progressive web app. It's also going to test whether our application is being served over HTTPS. And I think those are the three main ones, but also, for example, because it's so important that our application is always responsive and it's always showing something, if the user doesn't have JavaScript enabled, then we should still have a message for a user, either a text saying that JavaScript must be enabled or something must be shown to the user so that our application is progressive. Okay. You'll see that I've worked really hard on making this application progressive, so the score will actually be good for in terms of progressiveness. But in terms of performance, which is a very important step for building progressive web apps as well, I'm not doing great. I'm sure many of you have already heard about the 3 seconds mark. Are you familiar with that? What 3 seconds is? So I see some nods there. According to studies, whenever the user mostly starts leaving a page if it's been already 3 seconds since when the application is loading. So if the user cannot interact with the application within 3 seconds, they're gonna leave the website. Another fun fact about 3 seconds or 4 seconds, which my colleague Sarah shares a lot, is that when people have tested how the brain reacts after 3 seconds of waiting for a website to load, and it's basically the brain's reaction is the same as horror movie. So if you're experiencing distress, that's probably happening because of the waiting time. I'm not really sure what's happening here. I do have a video of this, just in case. So I'm connected to the internet. You know how people say that you shouldn't update your demo before a presentation? I'm sure that I broke my demo. Somehow. Oh, it's a breakpoint. Awesome. Right? How many seconds did we experience? Did everyone in the room feel like in a horror movie? Like, please run. She's still speaking. Okay. Do we still have a... Let me just refresh the page. Sorry? Okay. Okay, let's have a look at the video. This will work. So this is the Angular application you just generate with the Angular CLI, and I've added a progressive web app on top of that. I've added the progressive web app package and enabled it. And this is what you would get if you wouldn't change anything to your Angular app after adding progressive web app. And you can see here that the app by default is 88 out of 100 performant, which is better than my app. But also that progressive web app is only 82 points out of 100. Can anyone guess where's the missing 18? HTTPS, great. Anything else? What's happening? Well, one of the errors there was that my application doesn't have any fallback for whenever JavaScript is not enabled. So the solution was very simple. Just add some text saying that you should have JavaScript in like 2018. You definitely should have JavaScript enabled. Nothing's going to work for you anymore. The other error, as you've guessed, is that I didn't have HTTPS enabled. And I knew how to solve this as well. I just went to Azure where I deployed my app, and with a single click, I just enabled HTTPS. And that's it. My app is 100% progressive. That's fantastic, right? And it's checking some boxes, which are the minimum, the baseline appiness. But obviously, there's many other things that we should consider when we're building progressive web apps, and performance is one of the most important ones. Yeah, this is happy moment. Okay, what about progressive versus native? Because we're saying that the web strikes back, and we're building awesome applications using the web, and the web is great. But still, there's people building native applications, and there's a lot of effort involved into that. Like you're building an iOS application, you're building an Android application. There's two different teams working on different projects. People are still doing that. So why are they doing that? Well, looking at the state of the web, the Chrome version, or the Chrome state of the web, is fantastic. We're ticking a lot of boxes here. Things like Chrome covers offline capabilities, and it allows us to build applications that can subscribe to push notifications, and it also allows us to build applications that can be saved and installed on our home screen, and it allows us to background sync our data in our application. There's a lot of checkboxes there. The only thing that it doesn't support, which I should have Googled, is getting installed related apps. Does anyone know what that is? I'm going to Google it after that. But we can see that Chrome does great, but actually Firefox and Safari only have support for a few things that would make progressive web apps similar to native applications. So we have offline capabilities in both Firefox and Safari, which is great. So we can respond whenever the user doesn't have great network. And we also have support for push notifications, but only in Firefox. Safari does not have support for push notifications yet, but it does have support for payment request API. Because, yeah. This is URL that you can check yourselves on your mobile. It's a GitHub project, which I'm going to share with you when I'm going to share my slides. Yes? Oh, okay, so it's the notification where they're telling us. Yeah, yeah. Thank you. Okay, In terms of hardware, let's see, because when we're building native applications, most of the times we're accessing hardware features. And there's compelling reasons why we want to do that. For example, if we're building things like Google Maps, a Maps application, we definitely want to have access to the location of the user. If we're building applications that are like Snapchat, we want to have access to a camera and microphone. Currently, geolocation is supported in all browsers. So that's fantastic. The API is implemented in all browsers. We can see a user's location, and we can work with that. Camera and microphone, again, we can access a user's camera and microphone in all browsers. Edge, Firefox, Chrome, Samsung Internet. How many people here are using Samsung Internet? They're making a lot of effort in building a great web, and they're actually pushing the web forward. So I think that they definitely deserve credit for that. The other API that we might be interested in using is Bluetooth. And until now, it's supported only in Chrome and in Samsung Internet. All the other browsers are either considering implementing this API, or it's already in development. Other features that we might be interested in are NFC. Are you familiar with NFC? It's near field communication. It's the contactless payment, for example. It's only supported in Firefox. Ambient light sensor, so basically when our browser can figure out whether it's super light and maybe dim our brightness, it's only supported in Edge and Firefox. Proximity, whenever we're using, for example, Facebook, we can see that if we're speaking very close to our ear, it won't use the speaker, but then if we're maybe keeping our phone further away, it will use the speaker. So with Proximity API, we can figure out whether, like what's the distance between devices and react based on that. Currently, only with Firefox, we could implement something like this feature that's already available for native. What about software? Bam! We have support for push notification in all major browsers, so Edge, Firefox, Chrome, and Samsung Internet. In terms of support for Safari, we don't have support for push notifications in Safari, and there's no way around it. Save to home screen. You can save your applications to home screen currently, but there's no pop-up that's telling you, that's asking the user to save this application to home screen. We can imagine that we are savvy, we are tech users. We know how to go in the menu and save our application to home screen, but people like my mom or my dad, they're not necessarily very tech savvy, so they won't go looking into menus and see, oh, what's there for me? What's in the shop today? So they're never going to save an application to home screen because they're not prompted to. What about offline? Service workers are supported, and clipboard, like copy-paste, that's supported as well. What's not supported are things like contacts from a phone, from your own, the contacts that you've saved on your phone, or the calendar, or setting up alarms, or things like calling or SMS or listening to voice messages. Any of these features are not currently supported on the web. They're only supported in native applications. That might be a good thing, right? Because with all the privacy and security, we might actually be better off with the web than with native applications. App stores. I've recently met someone that was building an application for a progressive web app, and he was saying that literally he'd rather have all his application and all his users install the app from the App Store, because things like, for example, after you've added to home screen an application, if you delete it from your home screen, you're never going to receive a pop-up asking you to save it again. So there's no way to remind people that they can install the app. People are used to using an app store. 99% of us know how to install an application on whatever phone we're on. We go to an app store and install it. That might be an advantage sometime. So with Windows, we can install apps from the App Store, and on Chrome OS, we can install applications as well, progressive web apps as well. What about the push API? I've mentioned that it's supported only on Chrome. I've implemented a push API to on my website, which I hope it's still working on my progressive web app. Let's just close this. Okay, so home works. If you want, you can access this yourself as well. I can go ahead, and I have this notifications button or menu item, and then I can subscribe. And using serverless, I've written a function that uses web push, and it sends messages to all the people that have subscribed. So I'm receiving messages both in my Chrome. Just a second. I should. And on my Android phone as well. Otherwise, Sarah has a picture of my notification, which was a glory moment. Did anyone try to subscribe? Does it work? Well, I should send a new message again. So how this works under the hood, I have this notification component that uses the SW push service from Angular, and we can request a subscription, and this is done using the Google Firebase messaging, and we can use a package that's called web push. So the way the server communicates with the client is through a public key and the secret key. So the server will have the secret key and also the public key, and then it can verify that the communication is secure. So then we are subscribing to receiving messages, and this will create a subscription object for us, which we're going to store in the database. And then whenever we want to maybe send messages, we're going to use those subscription objects that we've saved in the database, use some endpoints that we've been saving there. So you can see here that I'm using Cosmos DB, and I have subscription objects that have been saved. And using these objects, I can go ahead and send messages to all the devices that have subscribed. So on the front end, we can use SW push, which comes from Angular. And on the back end, we use this library called web push, which is an NPM package. And we can use web push to send messages, to send subscriptions. And I can show you the functions that I've created in just a bit. I should have this in the browser as well, in the IDE. Okay. Can you see okay here? So we're using web push, and we have access to a public key and private key where we can verify that the subscriber is the correct one. And then we create a notification payload. So Martin should have received the "you are awesome" message, which I guess that he didn't, otherwise he would have confirmed. Yeah, no, I don't think so. I could just watch for logs here. Demo gods are never friendly. Did you get one? Yes, yay! You're just awesome, right? Yeah, so we can see in the logs as well that things have worked, but my PWA in the browser didn't receive any notification. I'm going to have to check why that didn't happen. Sorry? Yes. So here I've subscribed before. That was one of the issues that I had. To allow notifications, you have to change. You have to change your settings in the browser. So, for example, here I've blocked all notifications, and then you can allow them in the same way. Oh, okay. Let me see that. Oh. That's a good idea. I'm super awesome today. Yeah, it does. Okay. What do I have? What the last thing that we want to look into are gotchas. So the app install banner. In Firefox, you get this when you visit Progressive Web App. You get this screen where they tell you that you can easily add this website to your home screen, and it looks like a church with a cross. And they basically they show you where you can add your website to home screen. In Chrome, it's a pop-up that it's at the bottom of the screen, and it has the button to add to home screen. And then in Safari, there's no option there. You just have to go manually in the options and add to home screen. So this is already confusing. Like, you have 3 different browsers behaving completely different in terms of adding to home screen. I wish we had the standard way of doing things. The home screen icon, I've struggled with iOS. So Android, it will save your app using the icon that you've defined in the manifest.json file. But on Safari, it will actually save a screenshot of your application. And the way to fix this is by adding the list of icons using this link tag and adding Apple Touch icon. And this will add a new icon that looks great, looks good. You shouldn't add icons with transparent background. It won't look as you expected. It will add a black background like it did for my application as well. So Safari here, it needs more tweaking. Storage, we have different, based on the browser, we have different quotas for saving data, for caching our data. So for Chrome, we have less than 60, we can use less than 66% of our free space. The surprise here is Safari, which only lets us save 50 megabytes. And not only that, it will always delete all the data that we've cached, including our service worker. It will unregister it after a couple of weeks of not using the application. So this means that what we thought is progressive, Safari just doesn't care. Packaging. In Android, our progressive web apps are listed, are fully fledged applications, so they're APKs. We can see how much storage they're using. We can see the application. We can see how much data they're using. In Safari or in iOS, everything is listed under Safari. So you won't get to see for each app how much data it's using for you, at least for now. Another weird thing is that Safari doesn't keep state whenever your application goes to background. So you can imagine that you're filling in a form and you have to go copy something. For example, I don't know my phone number. And I always go copy it from the Uber application. With Safari, I couldn't be pasting it. I'm not. Okay. 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 So I can use this one. Okay, so which tools are available for us? Well, we've already seen Lighthouse. We've seen that we can test our application, audit our application using Lighthouse. It's available in the developer tools, but also we can use it as an NPM package. We can install it in our local and include it in our CI/CD process. PWA Builder, I didn't show it, but basically it's a tool that helps us generate both a manifest.json file, service workers. You can actually input a URL, and it will tell us, it will give us warnings or recommendations how to create a good manifest.json file or a service workers, and then we can download the entire configuration. A workbox is also a collection of JavaScript libraries that will allow us to do offline caching and offline analytics. It's just a wrapper that abstracts things, makes things easier for us, just like the Angular CLI does. So if you're using frameworks like Angular or Vue or React, you're probably better off using the CLI. And then another tool, another product that has invested a lot of effort into service workers is Pinterest. And what they have here is a library that allows us to write tests. It's called Service Worker Mock. We can use that to test service workers. And finally, I recommend having a look at Hacker News PWA. This is a collection of PWAs implemented in different frameworks. And you'll see there the Lighthouse score as well. And you can use this as a reference for best practices. The Angular CLI, we've already used it, but we can also use the Vue CLI and React CLI. All the CLIs are the best. And finally, progressive web apps are a new way to deliver amazing user experiences on the web. So yeah, that's the thought I want to leave you with from this presentation. Thank you.
Thank you. Test. Oh, yes. Hi. I just wanted to say thanks, because first of all, I think I solved a bug in my progressive web app. When you were talking about scope, I think, this might explain why I suddenly have weird things from my app when I'm going to subpath somewhere. That's good. But let's see if there's some other questions actually in the moment. Yeah. Someone else? No? No questions? Yes, one question? Yeah, I'll walk with the microphone. Okay.
So right now we have to build each time for production in order to test our progressive web app manually, or is there some watch or something?
So what I do is I have my application in a CI/CD process. So whenever I'm committing new change, I can just trigger build, and I can have my application deployed, and then I'm just testing it. So the only thing that I'm doing is checking in code, and then I can go ahead and test the application. With the improvements in the developer tools, chances of seeing cached data or old data are slimmer because we can do things like always update data on reload. So if I go here, I can check this update on reload, and what this means is that I'll always get fresh data. And also, I can, there's another option, this is not the right place to look for things. There's another option to not wait for new updates. So there's a lot of improvements in being able to develop with service workers locally. In terms of building your application, adding a file watch to build for production, you can definitely do that as well.
Okay, thank you.
No problem.
Yes, I have one on the front.
So I saw a lot of JavaScript. I was wondering, is there also a good support for coding in TypeScript if you want to make progressive web apps?
Well, Angular is TypeScript. It's written in TypeScript, but the configuration for Angular is actually just JSON, so it's very declarative. We're not using TypeScript for the service worker itself. I don't know. I don't know the answer to your question. I didn't come across any TypeScript.
You could, of course, just manually compile from the TypeScript to JavaScript. I've done it also for service workers. But just as basic, very basic. It's outside of your normal app, basically, from the rest of your app.
But I would imagine tools like Workbox would have TypeScript support. And if they don't, we should definitely do something about that.
Thank you. Any other questions at the moment? If not, then I would like to say maybe let's go to picking the topic for the second one and then a small break. Okay, guys and girls, let's say until 10 minutes past. 10 minutes past 8, I think, right? Yeah, so 15 minutes. There is drinks behind the bar, of course, and see you in a moment.